This whole amplifier project has been one step forward, two steps back, as everybody knows. I finally got the bottom portion working. This would be the phase inverter, the finals, the output transformer, the vibrato, and the power supply. This is the cable which sends the heater and DC plate to the 12AX7 here, as well as, excuse me, the controls for the vibrato. The signals come back along this coaxial cable. The problem was when I injected a circuit directly from this field tech right here into here, it worked just fine. From here, it was nothing. I needed to reflow several areas with solder. There were a lot of problems. I think they were exacerbated by the amount of work that needed to be done on this board itself, right? And there was a lot of work done on this board, and it was pulled around and about, things like that. I also added some heat shrink in some areas that were applicable to ensure that there wouldn't be any shorts. Long story short, I got this all cleaned up, tested the pots on the analog to see that the sweeps were good, and just because I was in there at that point, I said, let me go through these caps one more time, these ceramics, and they were. So I moved onward and forward, and this is where I start my my final testing on the scope. What I did was I'm going to keep the volume low, generate maybe half a watt. That way I could keep the speaker connected, which I do have. I don't have sufficient grounding, and this grounding cable here, I had mentioned it in the first video really early. There's a really terrible way that this thing was grounded, and what I did was, for the purposes of what I'm demonstrating right now, is you can see that I have this ground clipped right up here, and basically this wire comes around down and clips down to the bottom here, so that the ground potential between these two chassis are the same. The intent apparently was on this case that this cable here would wrap around this case and make its way up here, and both of these things would be grounded. My assumption was that originally that they would be grounded through a connector, a cable in here, which they're not. The second assumption was that all of the grounding would come through the ground on the signal cable, and it doesn't. So really weird. So I'll have to run a ground from one chassis to another, not a big deal. In the meantime, let's look at some stuff on the scope. We have the scope. I set it for 600 hertz. I put in 1/10 of a volt, which would be an incredible amount of voltage for a guitar, but we have a pot there. And as a matter of fact, I could probably turn it down a bit further, you know, and then probably 0.05 volts sine wave coming in, and then we can use the potentiometer that's on this control panel here. We'll bring it up first. We'll check out vibrato. We'll see how that works. We'll see a display of it, and we'll do a couple of things. So we'll do a demonstration of vibrato to the best of my ability. I can't match this to a guitar pickup, so I'm going to do the best I can here. And first we're going to bring in the 600 hertz waveform from my device, and we're going to try and get a nice height here. And I got the way I got the time set up, there's a bit of a delay, but this is so I could display vibrato, right? So here's the waveform with suboptimal triggering, but bear with me here. And now we'll turn the timing mechanism on the vibrato. We're turning it up. I'm sorry, that was the strength of the vibrato, not the time. So that's just the strength. And now, keeping that strength, we'll turn up the speed. And that's full speed at full strength. I'll leave the speed all the way up, and I'll bring down the strength. turning the strength all the way down effectively disables the vibrato, where the speed is at that point is irrelevant. So that now I turn off the speed, and that's the vibrato functionality. And that is those connections here, and that is channel 1. So that's vibrato. Tested out, working good. Now I will attempt with my electric guitar. I got a vibrato running, so you could hear this sort of weird shaking sound. You can see it on the oscilloscope. Now I will attempt with my electric guitar to play an A minor chord with the vibrato, with the pass filter on. So here we go. Sounds kind of cool. E minor. We'll turn the setting on the guitar up. Try it again. Setting on the guitar back down. A minor. We'll shut off the, just to see what it sounds like off. A minor, E minor. Pretty cool. See? The problem is my phone is making noise into the speaker because it's recording so close. G. I think that sounds pretty cool. I like that. And that's all done by this here 6AU6. Where is he? There he is, right there. So that's pretty cool. This coax connector's been so beaten up by time that sometimes it's a short, sometimes it's an open. I've decided to simply cut it off and re-terminate it. I'm stripping out all the solder and the connector inside, and I'm going to put the connector back onto the existing wire. This is going to be a very quick demonstration of hum and plugging in your amplifier backwards when you have the two-prong non-polarized. This is the signal cable, this coaxial cable that comes down into the amp here. Amp is off. Amp is off. It's not even on. We're plugged in. I have my oscilloscope lead. I just used an alligator clip, right? But oscilloscope lead is coming off the tip. I have the ring hanging open. I'll show you why in a second, right? So we're just looking at tip coming down to my oscilloscope, and I am seeing 35 volts AC sinusoidal wave. And you will notice that unlike amp hum that we usually exhibit, what we're looking at all the way down there is 60 hertz, right? As we're plugged in. I go and I take this, I flip the cord around, and I got nothing. Amp is still off. Nothing was changed. We got nothing. I'll flip it back. So when they say you can reduce your hum by swapping the polarity of your plug to neutral, so neutral is on neutral and hot is not to chassis, there you go, you're seeing it right there. I thought that would be a nice example since I was set up for it. So in trying to chase this noise on the top end, I may have found a short in the coax cable. It's hard to show both of them in this picture here, but if I bend this right here, see me holding it and then I bend slightly, the noise is gone. I bend back a little bit, noise comes back, and it is 60 hertz on the nose, right? So the the connector is the connector to the oscope is tip to the scope, and ring is to the ground. And I'm right here, and I've tried playing with the top portion here, and I didn't get any change on the top, and I didn't get any change on the bottom. It's right here. So this is 60, and this is by 5, right? So the graticule is 5, right? So 510, you're looking at 50. Peak says 17 volts AC, 60 hertz, and then a bend up, and it's gone. 17, and it's gone. So let me see what I got there. So the amp is finished. We've removed the gremlins that have been living in here. The coax and the connector ended up being replaced, as well as the RCA jack down here. The RCA jack and its connection to the 12AX7 were also replaced, as well as a resistor that connected from there to here as well. That also required replacement too. A lot of solder needed to be reflowed throughout this entire amp, most notably up top here. Down here in the second stage, this phase inverter area here, this this high gain section here, the area around the bias section over here. Just a tremendous amount of work. The problem with this amplifier, in summary, is all of the parts in this amp, even when it was new, was of really low quality. And when you work on it, the thing is either going to fall apart on you as you work on it, and you're going to end up replacing everything in the amplifier. You're going to end up replacing all of the tube sockets, all the resistors, all the capacitors, all the wires, all the cabling, all the potentiometers, all the jacks. By the time that you're done working on this amplifier, unless you're extremely careful, you're going to end up with an entirely brand new amplifier. So you have to work very gingerly. Another issue with this amp is the solder that they used. After it's heated up, after all these years, if you work in and around it, bend it or flex it, it cracks off like dust. So anything that you work on, bend on, or touch, all the solder needs to be reflowed, and it really was a ton of work to bring the amp into a perfect balance where everything was working again. It was not an enjoyable amp to work on. I don't like the fact that it was split like this, that the coax ran down like that. There were tempest issues, there were shielding issues, and what have you. As far as design goes, how they set it up, the vibrato circuits, all that sort of stuff, it's a push-pull. The bottom half itself, there's nothing really special about it. But other than that, like I said, it was a frustrating amp to work on. It's not a high-quality amplifier. I would be perfectly fine if I never saw another Danelectro amplifier ever show up in my workbench again. That being said, I'm glad it's done. I'm glad it's going back out. I'm glad it's restored. I'm glad it sounds nice, and I'm glad that it went from an amplifier that I came to discover was in a non-working condition, that there was no schematic for and continues to be no schematic for, that I had to work through, not having any idea of what the values were as per the company, and turn this into something that has a real nice sound to it. So that is the Danelectro Series E Model 272, made in Red Bank, New Jersey. Now it's time for a test drive. Let's see if I have a pick. We're calling this amplifier done. Thanks for everybody who's been following along. What a mess this one has been. Stay tuned for the next one.